Chapter 5, Section 5. Here's where we're going to look at complex numbers and roots. You're going to be introduced into a whole new set of numbers that you couldn't even comprehend before. So, let's get started. Complex numbers. What are complex numbers? A lot of people think complex. Oh, complex, that means hard. No, not so much. So if it doesn't mean hard, what does complex mean? It means it has multiple parts, kind of like an apartment complex. There's multiple apartments. And so what would those multiple parts be? Well, a complex number would be something like 12 minus 3i. There's this 12, and then there's this minus 3i part. There's two parts to that number. The 12 is called the real part, because 12 is a real number. The 3, or negative 3, is called the imaginary part, because it has that I. Now, that I, notice it isn't technically part of the imaginary part. If you forget and you put it with it, it's really not that big of a deal, but technically the imaginary part is just negative 3. And so, what is this I? Well, for pretty much your entire life, you've been told that the square root of a negative number is not a good thing. You can't do it. Square roots, you can't have negatives under your square roots. Well, that's not entirely accurate. Your teachers may or may not have been lying to you for the past, like 13 years of your life. So, but still, what times what equals negative 9? Well, it's not going to be a real number, that's for sure. And that's really what your teachers meant. When you can't do it, they didn't actually mean you can't do it. They meant that it's not going to be a real number, and that's all that you knew how to deal with. Well, if it's not a real number, what kind of number is it? Well, if it's not real, it's an imaginary number. I'm not making this up. It's actually called an imaginary number. So, what exactly is this I? I is defined to equal the square root of negative 1. This 3-lined equal sign means it's a definition. I is defined to equal the square root of negative 1. Now, imaginary numbers are fantastic because this whole system was developed, and usually throughout the history of math, the math is developed to solve a problem. Well, the imaginary numbers were developed, this whole system that makes sense, and it didn't have a use. People just thought, oh, well, what happens if we do this? Let's see, let's play with it. And they did it. And for hundreds of years, 200 years, it did not even have a use. And then all of a sudden, people started finding uses for it. In electrical engineering, they use imaginary numbers, along with a few other things. We're not going to do much with them right now. We'll see them again at the end of the chapter, and we'll be playing around with them a lot more then. So I is the square root of negative 1. So how does that work with simplifying? Let's start with the square root of negative 9 that we were working with earlier. How would we simplify the square root of negative 9? We can break its square root up in multiplication. Negative 9 is just 9 times negative 1. So that could be the square root of 9 times the square root of negative 1. The square root of 9 is 3. The square root of negative 1 is I, like we just saw. So it just comes out to be 3i. What about something harder, like square root of negative 50? Well, this negative is just going to give us an I in the answer. We can deal with the 50. Well, let's look at the 50. What does a 50 factor into? 5 and 10. I say 5 and 10. Maybe you say 25 and 2. That's okay. When we factor the next piece, the 10, we're going to get 5 and 2. Regardless of how you factor, you should have 2 5s and a 2 there. Hey, we have a pair of 5s. Well, remember, the square root's like a prism. A pair of 5s make a break for it. One of them gets to the outside, the other one gets shot and dies. And so we end up with 5 root 2i or 5i root 2. Some people prefer the I at the end of the square root. Notice it is not inside the square root. That way their 5 root 2 is the imaginary part from up here. Some people prefer 5i root 2 because we like having the square root at the end so we know exactly what's in it, what's not in it. This makes sure that that I is not inside the square root. It's not confused. I really don't care which way you use, but if you put the I at the end of the square root, make sure that it's definitely at the end of the square root, not inside of the square root. If your handwriting is sketchy, you might want to watch that. And so we're looking at these and we might be thinking from last time, wait, I thought when we take the square root, we have this whole with a plus or minus. Why don't we have plus or minus here? Well, there's two things we're doing. We're simplifying. We have the square root of negative 9. That's 3i. The square root of 25 is 5. The plus or minus comes when we are solving. When we have x squared equals a number and we have to take the square root of both sides, that's when we get the plus or minus, not when we're simplifying. Square root of 16 is 4. If x squared equals 16, x could equal plus or minus 4. Same thing here with this negative 9. So that's the difference. You get the plus or minus when you take the square root of both sides of the equal sign. There's an importance on keeping our notation right so that we don't randomly get stuff here. Notice simplifying, there's no equal sign. There's no equal sign in any of these problems over here because we're not solving an equation. We are simplifying an expression. So, big difference, but it's small little technicalities. All right, so we have complex numbers. How is this going to tie into solving equations and finding roots? Well, it's actually going to be pretty much just like what we were doing the other day. We're going to be completing the square. The only difference is when we get something squared equals a number, the number might be negative. That is really the only difference. So let's look at some completing the square problems again. Oh, and just regular solving problems. 5x squared equals negative 80. Well, first step here, we could take the square root of both sides, but I'm looking at 5 and I'm looking at negative 80, thinking I don't want to take the square root of either of those. So another first step we could do there, just divide by 5. X squared equals negative 16. Hey, I can take the square root of 16. So when we take the square root of both sides here, notice we get our plus or minus. X equals plus or minus the square root of negative 16, which would be plus or minus 4i. Now, for something like this, you don't need to show this step here where you have plus or minus the square root of negative 16. I get you can take the square root of 16 to get 4. The negative, that's going to be an I. And then don't forget the plus or minus. But if you want to show it, feel free. So I mean, that's a very simple, just solving it by taking a square root problem. All right, now for completing the square. Same exact process as before. So if you want to see it again, here it is. G of x equals x squared plus 6x plus 34. First step in completing the square. Well, first step in solving, the g of x has to be 0. And then for completing the square, we need to take the 34 and move it to the other side because we want our x squared and x to be alone on a side. Notice I left a space because something's going to go there. Well, remember we do these two steps at the same time. This is a different method than the book will show you. I found that trying to write this down step by step is very, very difficult. So we have the second step. We're going to have our x plus something squared. What goes inside the parentheses with the x? We take this plus 6, divide by 2 to get plus 3. Well, x plus 3 squared does not equal x squared plus 6x. It does equal x squared plus 6x plus 9. We need to square this 3 and add it here. And if we add it here, we have to add it to the other side as well. So now negative 34 plus 9 is negative 25. Now we can take the square root of both sides. This is where it's different today than it was the other day. The other day we would have had it equals 25 or it equals positive something else. Now it equals negative. Doesn't matter. We're just going to get an I in our answer. We take the square root of both sides. We get x plus 3 equals plus or minus negative root plus or minus root negative 25. Well, the negative is just going to make an I. Square root of 25 is 5. So x plus 3 equals plus or minus 5i. Subtract the 3 to the other side. X equals negative 3 plus or minus 5i. You can't simplify that. It's just like if it was a root. The i's we can treat pretty much like a variable. And we'll see that later on in the chapter when we're working with them too. You can treat them pretty much like a variable with very small exceptions. So try this problem. X squared plus 49 equals 0. It's going to be kind of like this one up here. So go ahead, pause your video and try it, and then push play when you're done. All right, was that one pretty easy? It should have been pretty easy. First step, subtract 49, then square root both sides. Don't forget your plus or minus. Square root of 49 is 7. The negative gives us an I. X equals plus or minus 7i. All right, ready for another one that's completing the square? So try this one. F of x equals x squared plus 2x plus 3. Now, this looks like you're going to be able to factor it, but you're not. So you're not going to get stuff like this by factoring. You're also not going to get answers like this if you try and use your calculator. The calculator will not help you find an answer like this. So go ahead, complete the square, follow the same steps, and pause the video, hit play when you're done. How was that? Is completing the square getting easier? I hope it is. So first thing, we make f of x equal to 0, and then subtract the 3, leaving a space. We have our other piece here. The x squared's by itself, so we have x plus, divide this number by 2. 2 divided by 2 is 1. Oh, that shouldn't have shown up there. Anyway, square it. We had 1 to the top. Negative 3 plus 1 is negative 2. And now it disappears. That's obnoxious. Well, that's negative 2. Square root, we get plus or minus the square root of negative 2 equals x plus 1. Square root of negative 2, the negative is going to make an I. Square root of 2 isn't going to simplify, it's just square root of 2. So subtract the 1 over, we have negative 1 plus or minus I root 2. Or you could have negative 1 plus or minus root 2 times I, as long as the I is not inside the root. So aside from my animation here being out of order, how is that problem? Did you get it? You should hopefully be becoming more and more successful at completing the square. It should be easier and easier. Hopefully you're not even having to think about it too much anymore. So what other types of problems can we see today involving complex numbers? The first type, and this is a type that looks really, really hard, but it's actually amazingly easy. And that would be find x and y if you have this great big equation. Equals. We have a complex number equals a complex number. Well, the thing we have to see about complex numbers is that if these two things are equal, that means the real parts are going to equal the real parts, and the imaginary parts are going to equal the imaginary parts. So let's look for the real parts. The real parts don't have an I. So we have 5 times x plus 1 and negative 20. Those are the real parts. If these two things are equal, Those two things have to be equal. All right, then we can look for the imaginary parts. The imaginary parts, we have 3y and we have negative 15. So these two things have to be equal. Notice I didn't put the i's in there with them because remember, the I is not actually part of the imaginary part. If you did, you'd just divide by I and you'd cancel I and it really wouldn't matter. But technically it doesn't go there. So now we have two equations. And when we look, well, 3y equals negative 15, that's going to be really easy. 5 times x plus 1 equals negative 20. That also should be a pretty easy equation to solve. See how this thing that looked really complicated, it just turned into two fairly basic equations. The 5 times x plus 1 equals negative 20, we have two things we could do here. We could either distribute the 5, or I would divide by 5. X plus 1 equals negative 4. So x equals negative 5. 3y equals negative 15. Divide by 3. Y equals negative 5. That's done. We found x and y. Way easier than what it looks like. So don't get freaked out if you see a question like this. The other types of problems that you'll see will ask about the complex conjugate. The complex conjugate is just the other root. When we have complex numbers, when we have complex roots, like we saw on the other slide, we have things like 3 plus or minus 2i. That would be 3 plus 2i and 3 minus 2i. That's the other root. So to find a complex conjugate, you just change the sign on the imaginary part. Examples: 3 plus 2i, the complex conjugate. We change the sign here. It's 3 minus 2i. 7 minus I root 5. We change the sign on the imaginary part. 7 plus I root 5. How are they going to try and trick you? Something like I plus 6. Which part here is the imaginary part? That's the I. So the complex conjugate is negative I plus 6. People always want to change the sign, go, oh, it's I minus 6. Now make sure you're changing the sign on the imaginary part. What if we had something like 4i? 4i is the imaginary part. So the complex conjugate is negative 4i. These will become useful when we're, if we had to like rationalize a denominator. We're not getting there today. These just show up in answers. At the end of the chapter, we'll do this. But when you multiply by a complex conjugate, it'll get rid of the imaginary part. Kind of like when we multiply by the conjugate to get rid of a square root. It's the same idea. The only thing you'd have here would be, hey, 3 plus 2i is a solution. What's the other solution? 3 minus 2i. You could go x minus 3 plus 2i, x minus 3 minus 2i to get back to an equation that you would have started with. Same thing we did if the roots were 5 and negative 2. We have x minus 5, x plus 2, x minus 3 plus 2i, x minus 3 minus 2i. So these are what's happening with our complex numbers. Primarily today, it's the same thing we've been doing. It's completing the square, except we might have something squared equals a negative number. And we end up with an I in our answer, and we move on. So be ready for a group activity in class, and I will see you then.